More fractions. These are probably a little bit less well known, but maybe sound somewhat familiar. A proper fraction. Proper fraction is any fraction that the numerator is smaller than the denominator. So here's an example of four that meet that definition. Improper fraction is kind of almost the opposite of that. It's when the numerator is larger than the denominator. We typically don't love dealing with those, and we might change them into my next definition of mixed numbers, but you have the numerator larger than the denominator. And then I mentioned mixed number. That's what we can do is we can kind of translate from improper fraction to mixed number, and we'll talk about how to do that. But this first page is just about definitions. And when that happens, we should be left with a whole number and a proper fraction. So I have 2 and 3/4. If that fraction's still improper, it's not really a mixed number, and I might have to do a little bit more work to translate further. So here we are, converting an improper fraction to a mixed number. Right here I have 11/3. By definition, numerator is bigger than the denominator. I have an improper fraction. So to translate it into a mixed number, what I do is I start doing some long division. So as a classic, I put 11 inside the house, whatever you want to call it, 3 outside, and I want to think, how many times does 3 fit into 11? 3 times. I follow the process. 3 times 3 is 9. I subtract that from my 11, giving me my remainder of 2. So here I have all of the pieces of information I need to make my mixed number. I'm going to take my answer, which is the top 3, the one in blue. That is going to be my whole number. And then I'm going to take the remainder, which is 2, and I'm going to put it over the divisor, the green 3. And so I put it all together, I get 3 and 2/3. May have been a lot in one kind of last final step. That's fine, we'll see it again. We have 25 over 2 here. Again, I'm going to set up my long division, 2 outside, 25 inside. In this case, it's going to be a little bit more involved with the long division. I look at the first number inside the house. 2 fits into 2 one time. Multiply that through, subtract, I would get 0. And then I bring down the 5. So 2 fits into 25. So this one's going to be a little bit more of an involved long division process. We see 2 goes into 25. I'm going to only just look at the first digit. 2 fits into 2 once. So I subtract the 2, I would get 0. So then I would move on to looking at the 5. How many times does 2 fit into 5? 2 times. I subtract 2 times 2 is 4. I subtract the 4 from the 5, leaving me with 1. And again, now I'm going to take all of these pieces of information and combine to make my final mixed number. The blue part, the quotient or result, is going to be my whole number. The 2 is going to be the bottom of my fraction or the denominator, and the 1 will be my numerator. So I put all the pieces together and I get 12 and 1/2. Okay. So the interesting thing about mixed numbers and improper fraction is there's kind of an advantage to using one over the other depending on which case or what type of problem you might be approaching. So sometimes you want to take a mixed improper fraction, which is kind of hard to picture as a real number or whatever, put it as a mixed number, and then you have kind of nice whole numbers to compare. Or sometimes when you're doing kind of basic multiplication, division, adding, subtracting, it's better for you to have an improper fraction. So now we're going to go the opposite direction. So I have 3 and 2/3. So I'm going to kind of reverse the process. So before I was dividing, now I'm going to be kind of subtracting and adding. So I take my 3 on my denominator, I multiply it by the 3 of my whole number. 3 times 3 is 9. And then I take that 9 and add it to my numerator, leaving me with 11. And now I kind of put everything together again. The 11 is going to be my numerator. The 3, the denominator, isn't going to change. Put them together, I get 11/3. Let's see it again. 7 and 1/5. I take my denominator, multiply it by my 7. 7 times 5 is 35. I add the 1. 36. Take that 36, put it over 5. I get 36 over 5 in percents. literally translates to per 100. So anytime you see the word percent, you should think out of 100. Not necessarily 100, because you could have 50%, you could have 150%, but you should think out of 100. So if I had 93% and I wanted to represent that as a fraction, I would say that's 93 over 100. If I had 107%, and to kind of reiterate, you can have things over 100%. Usually people think, oh, 100% is the maximum effort or something like that. And that I guess that's true if you're thinking of just percents in that effort sense, but there's like a lot of different things to think about percents. For example, percent increase, you can have a very large percent increase, much higher than 100%. So if you see a percentage that's above 100, don't say, oh, that's not possible. Just put 107 over 100. And then if you wanted to get it in a mixed number, we could. We're not going to worry about that for this example. Okay, so if I want to convert a decimal to a percentage, so I would want to take a decimal 0.12, I would want to convert it into 12%. So the first thing we're going to talk about is converting percents to decimals and vice versa. So the process is a little bit easy, so I'm not going to write out the individual steps, just go through a couple of examples. So if you're looking at a decimal 0.12, in order to change it to a percentage, you take that decimal point and you move it to the right twice. So 0.12, move the decimal to the right twice, becomes 12%. 0.0013, move the decimals to the right 2 places, becomes 0.13%. 1.34, move the decimal to the right twice, and you get 134%. Pretty simple conversion. And the reverse is just as simple. If I want to get a percent to a decimal, technically what we're supposed to do is divide by 100, but we can use a similar trick. Take a percent, we move to the left twice, we get a decimal. So 52% becomes 0.52. 125% becomes 1.25, and 3.14% becomes 0.0314. And so as a general way to kind of keep things straight, if you're trying to say, do I convert it to a decimal or a percent, or do I move the decimals to the right or to the left? Typically, percents are going to be bigger, and so if you're going to convert it into a decimal, you want to move the decimal to the left. And typically decimals are smaller, so if you want to turn those into percentages, you move it to the right and you will have a bigger number. Okay, converting fractions to a percent is a little bit more of an involved process, but not really much more. So if I have this fraction right here, 3 over 4. So I don't know if you guys have seen long division with decimals in a while, but usually if you set this up and you said, how many times does 4 fit into 3? Well, it doesn't at all. So you kind of have to add decimal places to divide things out. So instead of looking at how many times 4 fits into 3, you think how many times does 4 fit into 30? If it's in 7 times 4 is 28. I subtract, I get 0.2. I bring down another decimal place, I get 0.75. And then, so that's getting me the decimal, but now we know that if we have a decimal that changes into percent, we move the decimal to the right twice, or technically we multiply by 100, and so we're left with 75%. And I did kind of sprint through that long division, I'm fully aware of that, mainly for the reason that we saw in kind of the fraction section. Just go ahead and divide it on your calculator. So go ahead and put in 3 over 4, you'll get 0.75, and then you can skip to that step of moving the decimal to the right twice. So let's see it again. Here, I didn't write out the long division because we have calculators. So 5 over 6 is 0.8333333. And so then we would, in order to change it into percent, we move the decimal over twice and we get 83.33%. And so typically in this course, and this is true of all the math classes I teach, I prefer to have at least 2 decimal places. And so you could argue that in that first step, you could stop at 0.83. And so your final answer would be 83%. I'm perfectly fine with that. Or you can do what I did in this example, and I kind of waited till around until the end, and lo and behold, I was left with the 2 decimal places I want. So if I haven't said that before, as a general rule, round your final answer to 2 decimal places, if needed. Okay, converting a percent to a fraction is the most involved of the 4 conversions. Not really that difficult though. Step 1 is we're going to take a percent, put it over 100. Step 2, we simplify into lowest terms, and that's it. So here we have 25%. We know that percent means of 100, so we put 25 over 100, and we reduce. And 5 fits into 25 and 100, so I divide the top and bottom by 5. I get 5 over 20, and then maybe I could stop, but I see that 5 fits into 5, 5 fits into 20, so I divide the top and bottom by 5, and I get 1/4. So to see it again, I have 120%. I set 120 over 100. I reduce, so 10 fits into both of those. Pretty simple to see, but 2 does as well, 5 does as well. Pick whatever you want to. It's just if you pick smaller numbers, you might take a few more steps, which is fine. I get 12 over 10. I see that. Okay, those are both even. I can divide those by 2. I'm left with 6 over 5. And then if the question asks for it, convert it to a mixed number, you get 1 and 1/5. Okay, so let's see one more. I have 2.4%. First step's still going to be the same. I'm going to put it over 100. But what's interesting about this particular example is anytime we have fractions, we don't like to have decimals in fractions, so we kind of have to resolve that. We have to get rid of the decimal. And so the best way to do that is to multiply the top and the bottom by a number to essentially, get rid of the decimal. So sometimes that number is 5, sometimes that's numbers 4, but as a general rule, instead of kind of having to guess and check, if you want to move the decimal place once, you would multiply it by 10. If you wanted to move the decimal twice, you would multiply it by 100. If you wanted to move the decimal point 3 times, you do it by 1,000, so on and so forth. You get it from there. And that's kind of the easiest way to get rid of that decimal, is you're not really getting rid of it. We're shifting it to the right once, and so 2.4 times 10 gets me 24. But if I multiply the top by a number, I have to multiply the bottom by the number. So we just got to keep that in mind when we're kind of using this strategy. So I get 24 divided by 1,000. I have to reduce. 8 fits into both of those numbers, and I'm left with 3 over 125. 24 divided by 8 is 3. 1,000 divided by 8 is 125. Okay, another example. So yeah, technically this process isn't really an operation, it's more of a conversion, but nonetheless, that we have a mixed number here, it makes our life kind of difficult to deal with that as a mixed number, so instead we're going to convert that into a fraction, 3 over 2%. And then I put that over 100. And I believe we saw something like this in the division section, but if we did not, well, I really have a fraction on top, which is 3/2, and a whole number on bottom, which is 100. So to deal with that, I'm going to say, okay, the whole number is going to be 100 over 1. And then I'm going to do the whole stay.flip trick. So I kind of did that all in one step, but to reiterate it, the bottom is going to be 100. I'm going to convert that into a fraction, say that's 100 over 1. I'm not going to change 3/2. I'm going to flip 100 over 1, and I get 1 over 100. And then I multiply straight across, I get 3 over 200.